Howdy, my name is Nick Santinello, and on the left we have a diesel truck, and on the right we have a gasoline car. And now I'm about to explain why a diesel truck is more thermally efficient than a gasoline vehicle. So both these motors right here are internal combustion engines. First we have the diesel cycle, and then we have the Otto cycle. The way the Otto cycle works is it uses a spark plug to ignite the air-fuel mixture. In the diesel cycle, an extreme amount of compression is used to ignite the air-fuel mixture. So the compression is only used in a diesel, while in a Otto cycle, only a spark plug is used. So like I've mentioned, both these vehicles have internal combustion motors, but it's important to note that they have different combustion ratios. So on our right, for an Otto cycle motor, you're looking at anywhere to a 6 to 12 compression ratio, while on a diesel cycle motor, you're looking anywhere from 15 to 20 compression ratio. And so the greater compression is needed because it raises the temperature to ignite the fuel-air mixture.
Now that we have the basic understanding of both the Otto cycle and diesel cycle, let's get into the finer details. So we see that we have two graphs where the x-axis is labeled as volume and the y-axis is labeled as pressure. So for the Otto cycle, process 1 to 2, in this phase the piston will move upwards so fuel-air mixture can be compressed. Compression causes the mixture to increase in pressure and temperature with no heat exchange. This is considered an adiabatic process, and an adiabatic process is a process in which no heat transfer takes place. In process 2 to 3, at this point combustion occurs due to the spark plug igniting the fuel. Combustion of gas is complete at process 3, which results in loss of thermal energy. In process 3 to 4, the thermal energy in the chamber is then used to do work on the piston. This process is known as the power stroke because it is at the point where thermal energy is turned motion that powers the vehicle. And in process 4 to 1, waste heat is removed from the motor chamber. At this point, a decrease in pressure occurs due to the loss of kinetic energy. And now, on the right side of the diesel cycle, process 1 to 2, this is considered the adiabatic compression process, meaning the temperature of the air increases during compression and reaches the ignition temperature of the injected fuel. And in process 2 to 3, fuel is then injected and combusted, which is considered a constant pressure expansion. At process 3, adiabatic expansion continues while temperature decreases. And in process 3 to 4, this is considered the adiabatic expansion process. At this point, thermal energy does work on the piston, which is known as the power stroke. And finally, in process 4 to 1, constant volume heat rejection occurs, so heat is removed by the system through the exhaust. Here is the thermal efficiency for the diesel cycle, which is represented by eta diesel. The air standard diesel cycle is the ideal cycle for a combustion engine. For the air standard diesel, K equals the heat capacity at constant pressure divided by the heat capacity at constant volume, which is equal to 1.4 at the air temperature of 300 degrees Kelvin. In this equation, we're assuming an 18 to 1 compression ratio, and also the cutoff ratio alpha equal to 2. And when you plug in the values, we see that eta diesel equals 1 minus 0.37, which equals 63% thermal efficiency. It is important to note that this calculated value is the result of an ideal equation, meaning it describes the behavior of a hypothetical diesel cycle, but it provides a useful approximation. In reality, automotive diesels operate around 30 to 35% thermal efficiency. Finally, here is the equation for thermal efficiency of the Otto cycle. Notice that there is no cutoff ratio because it is not applicable. After plugging all the values in, the thermal efficiency of the ideal Otto cycle is at 54%. Typical automotive Otto cycles operate around 25 to 30%. Given the calculated values of both the diesel cycle and Otto cycle, we see that the diesel cycle is more thermally efficient.